Hi friends, I want to take a minute and look at a factoring pattern that you might well know. It's the factoring pattern that's a difference of two squares. And so the difference of two squares pattern you might recognize as a squared minus b squared, which was equal to the sum of a plus b times the difference of a minus b. But I want to take a minute and really think about how we could prove this or how we could show this in a different way. And so I want to think about this geometrically for a moment. So I made a little diagram here, and because the difference of two squares is just a square minus another square, I've made a representation of that. I have a big square here that is x by x. And then I've got a little square here, which is a 3 by 3 little square. And so if I think about the area of the whole square, I can think of that as x squared, right, x by x. And then I'm going to take away the area of the small square in order to find the shaded region, or the remaining amount. So that gives me x squared minus 3 squared, or x squared minus 9. And so I can easily see how this left-hand side is constructed from the shape. But how do I construct this right-hand side? That's a little bit more involved to get our heads around. So let's take a minute and let's explore how this side comes into being. And sort of in the process, I hope that we'll prove to ourselves that this is really true. If instead of thinking of this as the difference, right, as this square minus this square, if instead I break up this region and think of this area as the sum of this rectangle and this rectangle, I can take a minute and begin to look at what some of the lengths here are. So this side is still x of the rectangle, right? The height, if you will, of this rectangle is x. But this width here, oops, wrong pen tool there. This width down here is the side of the square x minus this piece 3, right? And if I look at this rectangle here, this height here is the height of the square minus that length 3. In other words, this length and this length are the same. If I look at the width of this shape, the width here is 3 long. Okay? And again, the height of this whole shape is x here. Okay? So I'm going to just visually reconstruct this shape a little bit. By taking this piece and moving it down to the end of my rectangle. And when I do that, you see that this side x minus 3 is the same width as x minus 3, so this just extends my rectangle a little bit longer. And this length here was x, but now I'm adding on this 3 here. And this piece here, this side on the top, was x, but I've taken away the 3 from this side. So I have the two dimensions of this new rectangle as x plus 3 times x minus 3. And I hope that gives you a little bit more of appreciation of how geometry and algebra are intricately connected and how examining one can help us to really process the other one. Thanks so much.